All right, now we're going to talk about Unit 7, Day 6 notes. That is compound probability. Now, what we did yesterday on Day 5 notes is talking about simple probability, which means we have one event. Compound probability means you have more than one event. You can have 2, 3, 4, 5. I'm not going to give you more than 3, I don't believe. 4 is at the most of possibilities that something could happen. And then compound probability can be broken down into independent and dependent events. So an independent event is where you have two different events that are independent of the result of the second event is not affected by the result of the first. So that means that one event has nothing to do with the other. So like, for example, rolling a dice and spinning a spinner, they have nothing to do with each other, okay? Independent has no effect on the result of the first one, okay? And to find the probability of those two, you would find the probability of the first and multiply that by the probability of the second. So for example, we have a box that contains 4 red marbles. So I'm just going to write that down here. 4 red. We have 3 green, 2 blue, and 1 marble is removed from the box and then it's replaced. So this is one where I'm just going to take one and I'm going to put it right back and then I'm going to grab another one again. Okay, another marble is drawn from the box. What is the probability that the first marble is blue and the second marble is green? So let's find that as 2 separate ones. So we want to find the probability of the, so if we want to find the probability of blue then green, we need to find the probability of the blue and then multiply the probability of the green. So probability of the blue, that P parentheses means probability. So, sorry, I don't know what I was writing there. It's probability of blue. Okay, so blue, there's 2 different times a blue can be pulled out of 4 plus 3 plus 2. So that's 4, 5, 6, 7, 8, 9. So 2/9 of a chance that the purple or that the blue can happen. Now, sometimes you'll be getting a fraction that you can simplify immediately. You can do that or you can wait till the end to simplify. I tend to wait till the end to simplify. All right, and then the probability of the green, there are 3 green marbles out of 9 total, okay? And you're going to multiply those together. So when you multiply the fractions, you just multiply straight across. So that becomes 6 out of 81. Because 2 times 3 is 6, and 9 times 9 is 81. So 6 out of 81. Math, enter, enter. And that gives you 2 out of 27. Okay, and just to review how to simplify a fraction, if you don't have one of these little handy dandy calculators at home, list your factors. So with 6, we have 1 and 6 and 2 and 3, and that's the only 2 numbers that are only 2 factors of 6. And then with 81, you have 1 and 81. And then with these, I don't really know all the factors of 81, so I'm going to just go down the list. Divided by 2 doesn't go in. So 81 divided by 3 is 27. 3 and 27. 81 divided by 4. Nope. 81 divided by 5. Oops. 81 divided by 5. 81 divided by 6. 81 divided by 7. 81 divided by 8. I don't think any of these other ones. Nope, there's 9. 9 and 9, okay? So then we look and say, what's the largest number in both of these? So that's a 3 and 3. So that means that 2/27 is my fraction, okay? Just as a way to show you how to simplify your fractions without a calculator, or at least without a fancy calculator. You can do all that dividing with your phone calculator. Okay, so there's 2/27 of a chance of grabbing a blue and then a green. So then the dependent event means that we have 2 events that are dependent if the result of the first one, the first event, affects the outcome of the second event so that the probability is changed, okay? So this one's a little bit different. So basically it means a dependent event means that that first one is going to affect what happens to the second one. It affects that probability. So we have, again, 4 red marbles, 3 green, and then 2 blue marbles, okay? 1 marble is removed and not replaced, aka that means that my total is going to change. I'm just going to start out with 9, but then that is going to, because I'm not replacing it, that means I'm going to have 8 now, All right, so another marble is drawn from the box. What is the probability that the first marble is blue and the second marble is green? Okay, so first we need to find the probability of the blue. Okay, so again, blue is 2 out of 9 total, but I'm not putting that blue marble back. So then for the probability of the green, that means I have 3 green, but I only have 8 total now because I didn't put that last one back. So this bottom part is what's going to change because my total is what changes. Now say, for example, I said take out 2 blues. That means both of these numbers would go down 1. So you would have 1/9 or 1/8 as the next fraction because I only have 1 blue left and 8 total. Okay, just as an FYI, because you will have a problem like that in your classwork and such. All right, so we're going to multiply across, so that gives me 6 over 9 times 8 is 72. So 6 over 72 in my calculator, math, enter, becomes 1/12. So you have 1/12 of a chance of grabbing a blue and then grabbing a green without replacing the first marble. Okay, so then I'm going to flip over to the next page to do some more examples for you. All right, so we have one letter tile is selected and the spinner is spun. What is the probability that both will be a vowel? Remember, vowels are A, E, I, O, U. And then, of course, you got the sometimes Y, but we're going to just stick with the A, E, I, O, U. All right, notice we have tiles and a spinner. Does either one of those affect the other? No. So that means this is an independent. Okay? Independent. Oh, I spelled that all the way wrong. Dent. Okay, there we go. Independent. All right, so we got a couple different parts of this problem. So first, we want to find the probability of selecting a vowel from the tiles. So we only want to find a vowel from our tiles. So looking at our tiles, we only have E and A. So that's 2 vowels out of 1, 2, 3, 4, 5, 6, 7 total. 2 7. So there's 2 7ths of chance to select a vowel from the tiles. And then that's it, right? So then we want to find out the probability of spinning a vowel on our wheel. So if we look on our wheel, we have only A and E there. All right, so that's 2 out of 1, 2, 3, 4, 5, 6. So 2 6. All right. So then letter C wants us to find the probability that both letters are vowels. So that means we're saying if I pick a tile and I spin my spinner, what's the chance of me picking a vowel? Well, we just found out the probability of vowels from both of them. So now all we got to do is multiply. 2 7ths times 2 6, which gives me 4 over, I believe, 42. 7 times 6. Let me check. Yep, 42. All right. And then we simplify. 4 over 42. Math, enter, gives me 2 over 21. Always simplify your fraction. If it's not simplified, it's wrong. All right. So now let's do letter D. It says we want to find out that both letters are A's. So looking at our tiles, okay, there's only one A out of 7 tiles total. And then looking over at our spinner, there's only one A out of 6 sections total. So then again, we're going to multiply across. So that becomes 1 over 42. So you only have 1 out of 42 chances to get an A on both the tiles and the spinner. All right. Then it says in letter 6 that both are consonants. And consonants are basically anything that's not a vowel. So not A, E, I, O, U. So here, everything that's not A or E is G, B, S, L, T. So that's 1, 2, 3, 4, 5 out of 7 tiles. And then over here, we only have A and E in our spinner, so that's 1, 2, 3, 4 that are consonants out of 6. And again, we multiply across, so that becomes 20 over 42. Oops, didn't write that right. 20 over 42. So 20 divided by 42. Math, enter, gives me 10 over 21. Okay. So you have 10 out of 21 chance of picking both consonants, which is more likely than picking both vowels. Notice there you only had 2 out of 21 versus 10 out of 21. All right, so then let's look down here at example 2. We say a penny is tossed and a numbered cube is rolled. Find each probability. So again, a penny and a cube have nothing to do with each other. It's not going to change any effect. So that means that these are, again, independent. So we want to find out the chance of flipping a coin and getting tails. So you either have heads or tails. That's one out of two choices. You're either going to get heads or you're only going to get tails. All right? And then we want to find out if we're going to roll a 3 on a cube. So there's only 1 3 out of 6 choices. So that becomes 1 out of 12 chance that you're going to get tails and a 3 in our section. Okay? So then we want to find out the probability of getting a head. So again, you only have 1 chance of getting a head out of either heads or tails, so that's 2 chances. Then we want to find out odds. So remember, in our dice, there's 1, 3, and 5. The rest of them are all even numbers because you have 2, 4, and 6. So that's 3 out of 6 possible chances of that happening. Okay, so that becomes 3 over 12, which we need to simplify. 3 over 12, math, enter, becomes 1/4. So you have 1/4 of a chance to get a heads and an odd. So that's a better chance because it's a bigger fraction than 1/12 is. All right, now let's look at example 3. Let's see, yep. Example 3, and then we're done with the notes. So there are 4 oranges, 7 bananas, 5 apples in a fruit basket. Megan selects a piece of fruit at random, eats it, and then Terrence selects a piece of fruit at random. Find the probability that 2 apples are chosen. Since the first fruit is not replaced, she eats it, it's gone at that point. The first event affects the second event. That means they are dependent events. So this one automatically tells you they're dependent. Okay? So we want to find out, first of all, in part A, the first piece is an apple. Okay? So we have 5 apples. So that means there's 5 chances of apples being picked out of 4 plus 7 plus 5 options total, which is 16. So we have 5/16 of a chance to pick an apple. Note how many fruits are left in the basket now. After Emma chose 1 apple and ate it, that means there's only 15 fruits left after she eats it. All right, so we want to find the probability that the second piece is an apple. Well, she just ate 1 apple, so now there's only 4 left out of 15. Because she ate 1 apple, so that means that my total apples goes down to 4, and then my total in general goes down to 15 because I'm 1 less fruit. All right, so part C wants us to find out the probability of them both being apples. So that means we just take those 2 answers, 5 out of 16 times 4 out of 15, and multiply those across. So 5 times 4 is 20. 16 times 15 gives me 240. And then all we do from there is simplify. 20 out of 240 gives me math, enter, 1/12. So you have 1/12 of a chance of picking 2 apples, one right after the other. Okay? So then let's look at the next example. Letter D says that we want to pick 2 bananas this time. Okay? So bananas, I have 7 total. So I have 7 out of 16 in my first chance because I haven't picked anything yet. So I have 7 out of 16 total. But now I'm 1 less banana. So that means I have 6 bananas left out of 15 fruits total. So then to find out the probability of both of those being bananas, 7 times 6 is 42 over 16 times 15 is 420. Or 240, sorry, my dyslexia. 240. So 42 out of 240, math, enter becomes 7 out of 40. Okay. Letter D, or letter E, sorry, we want to know what's the probability of picking an orange and then an apple. So with oranges, we have 4 total out of 16 to begin with. And then we want to pick an apple. So we still have 5 apples total out of 15 total now because we ate that orange. So 4 times 5 is 20 out of 240. So 20 divided by 240 gives me, math, enter, 1/12 again. So 1/12 of a chance to pick an orange, and then an apple. All right. And then letter F, we want to find an apple and then a banana. So an apple, again, we start out with 5. So that's 5 out of 16 total that we started out with. And then we have 7 bananas still. So that's 7 out of 15 total because we lost one of those. We lost that apple, so that made my total go down. 5 times 7 is 35 over 240. So 35 over 240. Math, enter, enter, is 7 over 48. All right. And then our last one is if we have 2 oranges. So first we start out with 4 oranges out of 16, but then one of my oranges is gone. So now I have 3 out of 15 left. All right, so that becomes 12 out of 240. 12 divided by 240, math, enter, enter, becomes 1 over 20. So you have 1/20th of a chance to pick 2 oranges. All right. Again, if you have any questions on that, please let me know. I know I went kind of fast through those notes, so if you have any questions, please feel free to let me know. On your classwork, you're going to answer the questions that have to do with up here, 1 through 6. Answer the questions about the spinner and the die that's talked about. And then number 7 talks about rolling the spinner twice. Let me see if there was any typos I needed to let you know about. Nope, no issues on the first page. On the second page, though, I just wanted to let you know that on number 13, there is no replacement there, which automatically should tell you that that is a dependent event. So you need to know that. All right. The rest of it you should be able to do. Make sure you read these carefully. That goes 1 through 8, and then this says A, B, A, C, A, B. So A and B happen twice on my spinner there. Okay. If you have any questions, please feel free to let me know, and I will gladly answer them as soon as I can. Miss you guys. Bye.